So we need to define all three parts of an electrical circuit. If you were paying attention, hopefully you noticed that there are indeed three parts to the circuits that I was just discussing. We call them voltage, current, and resistance. So we're going to begin by defining voltage. Voltage is also known as electrical potential, and the easiest way of thinking about this is that it is like a type of potential energy which motivates or pushes the electrons along through the circuit. It gives them pressure to flow. In other words, voltage is just like the potential energy or the pressure that the water received from my water pump here. Voltage was provided by the battery or the pump here pushing the electrons up to a high potential energy so that they had the motivation to even flow down in the first place. That is what voltage does. It gives the electrons a motivation, a driving force to push them along through the circuit. Voltage is always provided by some power source or some battery. You have to spend energy to pump those electrons up. Your battery, your power source will give that to you. And we measure it in a unit known as volts. My next variable that I'm going to study is known as current. Current has an abbreviation I. Capital I is current. Current is defined as just the flow of electrons. So remember with my water example, the pump provides high potential energy, high pressure. As a result of that, we get a flow of water. The battery provides voltage. As a result of that, we get a flow of electrons. We call that flow the current. And so the current is defined as the flow of electrons in a circuit as long as they are motivated by the electrical potential. So similar to water flowing through pipes or down a stream, the more potential you have, the more pressure, the more potential energy, the more motivation those electrons have to flow, the more they're going to be flowing. The more electrons are going to be flowing. You can almost think about it as if the faster they're going to be flowing. So more potential means more current. And current is measured in amperes. Sometimes we call it amps, and that's given with a capital A. So current itself is defined by capital I, and amps, the unit of current with which we measure current, is capital A. And then finally, the third variable that I'm concerned about right now is resistance. Resistance is just what it sounds like. Resistance is a measurement of how much the electrons are being resisted in their flow through a circuit. So anything that resists the flow of electrons through the circuit, or anything that's drawing energy away from the electrons and therefore reducing their potential. So let me go back to this picture. Do you think you can guess what this R stands for? Remember what these represented. These represented almost like water wheels turning, extracting useful energy. And also, they occurred wherever there was a drop in elevation or a drop in potential energy of the electrons. So these represent resistors. They resist the flow. They reduce the potential of the electrons. They slow the electrons down, extract useful energy from the electrons, and as a result, the electrons have a lower potential energy. After this resistor, R1, the electrons are at a lower elevation, a lower potential energy. After this resistor, R2, their potential energy is 0, and the battery's got to pump them back up again to give them a high potential. So a resistor is anything that slows down or resists the flow of electrons while kind of extracting useful energy from those electrons, thereby dropping the electron's potential. So we say that resistors cause a voltage drop because they exert a resistance and they extract useful energy that causes the potential energy of the electrons to kind of decrease. And remember, potential for an electron is defined as voltage, so resistors cause a drop in voltage. Again, it's similar to a water wheel extracting useful energy from flowing water. The bigger the resistance, the smaller the current. We'll talk about that later. And resistance is measured in a unit known as ohms. Ohms has this odd abbreviation. That is the Greek letter omega. You draw it just like this, over, around, over again. That's a really crappy omega, but you get the idea. Omega is the abbreviation for ohms, which is the unit that we use to measure resistance. So I know I went through that all pretty quickly, but I hope it makes pretty good sense. Whenever you are thinking about an electrical circuit, you've got to think about three things: the battery, or you've got to think about three things: the voltage, um, which is also known as the potential, the electrical potential that's provided by a battery. It's like a pump pumping those electrons up to a higher energy, higher elevation, so that they feel motivated to flow. We have a flow of electrons. These electrons are going to flow from this region around, down here, and around and back. That is the current. So we have voltage, we have the flow of electrons known as the current. What's the abbreviation for current again? Capital I. And then we have the resistance, things that are causing the electrons to slow down, to experience a drop in their potential, all the while extracting useful energy. So voltage, current, resistance, these are the three parts, the three variables to any electrical circuit. So my battery is providing an electromotive force. It's providing a potential that's giving the electrons motivation to flow around the circuit like this. So here's my battery providing a voltage. Here is my current. And then what do you think my light bulb is doing? That's my resistor, right? R. So the electrons flow around. They're pumped up in energy. They flow around. They're pumped up. They flow around. What is causing them to experience a decrease in energy? What is causing their energy values to drop or be reduced? The resistor is, right? Remember what we said earlier. Wherever there's a resistor, the electrons kind of experience a drop in electrical potential. It is exactly as if there's water at a high elevation and then it flows downhill, and now it's at a lower elevation. Here it would have a high potential energy. Here it would be a low potential energy. And that drop would be caused by a resistor. So my resistor is causing a drop in potential. That is what a resistor does. So look at this little graph. This graph shows you the potential energy at different points along the circuit. Point A, point B, point C, and point D. Point A and point B, between point A and point B, nothing really has caused those electrons to drop down in their potential. They all still are flowing with a high potential provided by the battery of 1.5 volts. But then what happens as the electrons flow through the resistor, through the device that's extracting useful energy from point B to point C? They experience a voltage drop. So wherever the resistor is in your circuit, the electrons are going to experience a voltage drop, and that potential drops dramatically. And then from point C to point D, they still have no voltage. And then what's the battery's job? What is voltage? It is providing them with potential again, with a motivation to flow around in the first place. So between point D and point A, those electrons get more potential energy. It's like a pump, pumping the water up from low elevation or low pressure to high elevation or low pressure or high pressure. So you've been introduced to the three variables: voltage, current, and resistance. And now I want to show you how to kind of put them all together into a diagram. So these are known as circuit diagrams, and I think they're pretty simple and pretty fun to draw. So remember that every circuit needs three things. We need voltage, we need current, and then we need a resistor to extract useful energy. So voltage is always provided by a power source like a battery. And so in my current, I'm going to represent the battery with two bars like this, a long bar and a short bar, just like that. So that's going to provide my source of voltage. That's going to be like the pump, pumping the water up to a high potential energy state, or providing it with pressure, motivation to flow. This is providing my electrons with motivation to flow. That's voltage. It's potential, electrical potential. Well, those electrons are not going to flow unless they have a path to flow down. So I need some wire. I need a path for them to flow on. And I'm going to represent that just with a loop going around like this. And that represents the current, the flow of electrons. It's always going to go from the big side of the voltage symbol to the small side. So my current is traveling around like that, and I can represent it with an arrow. Remember, current is represented with an I, so I have V, I have I. And what am I missing? I want you to think about this. What if I had a circuit set up just like this, a battery? So here's my battery, right? That's what the voltage represents. That's what this represents. And then I just have a wire, a loop of wire, connecting the battery back around to itself. What do you think would happen? Well, do we have electricity flowing? Yeah, we kind of do because I have a closed loop and I have a power source. But what's the problem? I don't have anywhere for that energy to go. Remember, flowing electrons flowing around in the same direction is a source of energy, useful energy. So if there's nowhere for that energy to go, what do you think is going to happen? It has to go somewhere, so it's going to get converted to heat energy. And it's going to get converted to heat energy pretty dang quick. This whole thing is going to get really, really hot. And the battery is going to start malfunctioning very quickly. It's basically spinning its energy very, very quickly, turning all that energy into heat. So that's bad news bears. This battery may even explode under certain circumstances. So I definitely do not want that. So what is my circuit missing? Well, it needs something to extract that energy out. It needs a resistor. There needs to be a drop in voltage, right? So I'm going to add a resistor right here. And a resistor, really simple, is just kind of like a squiggly line. So my resistor is going to be drawn. So my resistor is going to be drawn like this. There's my resistor. So I have a voltage. What does the voltage do? It pumps the electrons, gives them a motivating factor and driving force to flow around, gives them potential energy. As a result of that, I have current flowing, and then my resistor is slowing those electrons down, extracting useful energy. It's providing a voltage drop. So the electrons from this point here to this point here would experience a drop, a decrease in potential, and they're going to flow back to the battery, to my source of voltage, so they can get pumped back up again. And they go around, they drop in voltage, flow back to the battery, get pumped back up, and on and on and on. This is a circuit diagram: voltage, current, and resistance.